But looking now backwards at what's happened in the last year or two, I wanted to just touch on a few things. First of all, we're seeing maturity now in that cloud space. Now you can go and sign up for services in the cloud. Get yourself a server, get infrastructure as a server or software as a service in Azure, Amazon Web Services, and Google. Another area is blockchain. I think this has come quite a way since Bitcoin, and we're starting to see it now show up as possible use in contract negotiations and following contracts. We're seeing it in real estate, in banking, and tracking energy. So we're starting to see this become a technology spreading out as an interesting thing to support new directions in technology. Smart agents. We mentioned Siri. We have Cortana, Google Now, Alexis. A lot of things are happening now where you can talk to this agent. They will find the answer for you or go do something for you. Building on that is home networks. Amazon's Echo, for example, and Google's Nest Labs, Apple's Smart Home and HomeKit, Logitech Harmony, the kinds of things that right now are kind of kludgy. So us techies don't mind adopting them. But at some point, they're going to get easy enough for people to use as part of their home. And then I wanted to spend just a little time on the new Supreme Court ruling. You remember a couple of years ago, Apple sued Samsung and won a $1 billion or $2 billion award, which got whittled down to like $750 million, because design patents, as opposed to utility patents, design patents, the idea is if you copy somebody's design patent, then all of your earnings for that product go to the person you wronged. So in theory, all of Samsung's earnings, all their profits on this smartphone that used this rounded corner or whatever it was, would go to Apple. Well, the Supreme Court just this week finally ruled no, design patents have to go as utility patents have done. That is, you look at the percentage of contribution of that particular aspect of the product, not the whole product. And now it's going to go down to maybe $20 million in damages. This is really big for technology because this opens up a lot of things where you can either cross-license for a much lower fee, or if you get caught copying something, it'll cost you a lot less if it's a design patent than if you had otherwise. That left a lot of uncertainty. So this should open up a lot of floodgates, much like the non-compete clause not being enforced in California opens up a lot of technology. Very important. So where are we going from here? What do we expect in the next couple of years? I'm going to spend about 10 minutes talking about where I think technology might be going. So the key fields for the rest of the decade, the next 3 to 5 years. The first platform I'll talk about is cellular and then vehicular technology, and then talk about some other technologies. So looking at the platforms, the smartphone has really been a great platform for the last decade, and we're seeing it in quite a few areas, taking over with its apps, a lot of management, a lot of information, a lot of structure. Well, I see it expanding more into wearables. We have Fitbits and things like that, but I see it expanding now into garments, into hospital beds, into implantables perhaps, to monitor health, focusing on e-health and that sort of thing. So I think there's a lot of mileage still. I think that's where that direction is going to go for that platform. And I bring Samsung in as an example. Here's a company in South Korea that would like to bring lots of technologists together to work on their operating system. But when they acquire a company, it's really hard to get them to move to Korea. So they did a better thing. They built a 1.1 million square foot facility, putting in about $300 or $400 million, which can handle 2,000 employees. They're going to work on their phone OS. They're going to work on e-health, because that's a big issue in Japan, robotics and so on, to help older people that retire. They don't have enough younger people to take care of them. And they often will acquire technology by acquisition hires. They'll buy this little company, this 2-year-old company with 19 people, and say, okay, you're on the second floor in the south wing. They'll buy another company, okay, you're on the north wing on the 7th floor. They've got a 10-floor building to put these all into. And you'll get this synergy, this cooperation, this unified Samsung Advanced Technology Lab. And it's growing right now in North San Jose. They dedicated that last September. And so you'll see that kind of thing happening. Samsung's one example. I'll talk about another in automotive. So the next 5 years, I think automotive is going to be one of the biggest and best platforms for some of the technology that's rolling out. We already see Tesla incorporating some of our intelligent agent technology in their autonomous mode, the semi-autonomous driving. I point to Wrightspeed, developing electric drivetrains and power for mid-sized delivery trucks. Think FedEx, UPS, United States Postal Service perhaps. That's a San Jose company doing testing on that now. Self-driving trucks, Otto, a Bay Area company, was just bought by Uber. Just drove, 15,000 cases of beer to Colorado, Budweiser, with completely autonomous driving, with, of course, a driver watching. But we're going to see this in the next 3 to 5 to 7 years, this more autonomous trucking happening. The next 5 years, all the automotive players, the major ones, are in Silicon Valley. Nissan, GM, BMW, Delco, Volkswagen, and Mercedes-Benz have been here for a dozen years. Ford has a major expansion in the industrial park right next to Stanford. They're going to have about 200 development people there as their advanced technology group working on automation and self-driving. They're partnering with Baidu, and they have a partnership now with Velodyne LiDAR, which is in Morgan Hill, which is Silicon Valley, right? Morgan Hill. So they're pulling all this technology together to inform the designs that will be built who knows where. Maybe coming out of Detroit, but they'll be built in Tennessee and Europe and China. But the technology, a lot of it's being developed right here. Toyota is investing $1 billion over 5 years, most of it here in the Stanford area, some of it in Boston near MIT, to develop artificial intelligence, robotics, for their, not just for their automobiles, but for their production plants and for the Japanese population that's going to need more robots. They bought Harman, old Harman Kardon stereo systems. They do JBL, but they have a car operating system, basically, that's in many of your cars now. And they bought Harman, which is now investing in NAVD, which you see a heads-up display here, which you can get as aftermarket equipment for your car. It goes on the dashboard, plugs into your diagnostic and maintenance port, hooks up to your cell phone, and now you've got all that stuff sitting right there on a heads-up display. Very nifty. That's a local company. Autonomous driving modes using LiDAR, better LiDAR systems. Inter-vehicle communications. We're seeing more of this starting to develop, different ways to communicate between vehicles to give status so we know that that car is going to change into the right lane. I can do this. NVIDIA has their Drive PX2, which I show here, which becomes the brains of your autonomous car. They sell that on the market. They have other versions. Intel is getting into this market too. They have a number of educational systems. They have a SDK. Self-driving. Uber now has bought Geometric Intelligence, basically for Carnegie Mellon and East Coast companies. They're moving to San Francisco. This is going to be their artificial intelligence and deep learning system. Google, fully automated. That's their objective. Who needs a steering wheel and a brake? It's going to run itself. Apple has bought 3 artificial intelligence companies in the last year, so there's a lot going on there. We're seeing a lot in virtual and augmented reality. Virtual reality is kind of neat. I've got a Google Cardboard that I use with my wife's cell phone, and it's neat. But augmented reality, I think, is maybe the more appropriate thing that we're going to see rolling out for head-mounted and heads-up displays, incorporation into eyeglasses, where it puts stuff, maybe what's inside that building I can see here, or I can see, for example, in medical, I can look inside an arm and see where the blood vessels are. The surgeon can look inside the body and see where that part of the intestine is. This is all part of that heads-up or eyeglasses implementation of augmented reality, using information from other systems to show us what's going on. I think deep learning is a hot area. You have multiple hidden layer architectures, artificial neural networks, which are being developed. NVIDIA has its own engine now for that, DGX1. Intel has an SDK and quite a bit of information. Google has their DeepMind system, which they've opened up now for others to use, and IBM's Watson. I'm not saying IBM is a Silicon Valley company, but it's part of that technology. They're very useful in the area of natural languages, either translating languages with deep meaning or writing in languages, creating documents. Also, as I mentioned, in health diagnostics, one good area is X-rays. They've shown that things like Watson can look at X-rays and find anomalies that the doctors may often miss. So it's a very good second opinion on looking at X-rays for oncology, for broken bones, for anything. Also in customer relationship management, a great opportunity there to improve the ability to address the needs of your customers, know how to zero in on what they need that you're providing. The sharing economy provides another interesting area of new technology, that peer economy. We have Airbnb, sharing your couch. Used to just be for, as you may know, for a bed and breakfast, and they required you to have an air mattress for that. You couldn't make it a couch. That's why it's called Airbnb. But they decided, okay, beds are okay too. And then we have Uber and Lyft and Wings with this just-in-time, the independent contractor coming around and picking you up within 5 minutes. So what's going to happen to car ownership? I mean, in 5 or 10 years, you may not need 3 cars. Maybe one's enough. You have your coffee. Your Siri knows that you've turned off the coffee machine. They call Uber. In 4 minutes, they're out in front with 2 other people. And you hop in, and there's no driver. It's one of these autonomous cars. And they whisk you off to work, 12-minute commute, and you just talk or play cards or read your tablet, and they get you to work. But also crowdfunding is part of this shared economy. The idea of being able to be an early investor, and for $50 you get one of the alpha products from this company, and it gives them the money along with the other 4,000 people to start their company and start doing stuff. Artificial and machine intelligence, real important, and a lot of that's now moving open source. Released on GitHub and other venues. You have OpenAI and the Universe construction system that Elon Musk released. You have TensorFlow, which was released earlier, and now DeepMind and the lab to support it coming out of Google. These are available for you to start working on this machine intelligence. And you have cloud platforms now to support them. So I think this is going to be an area of great opportunity for making new markets in this area. Another area is drones. We're starting to see them fly around and land in the wrong places and get in people's backyards and get lost. My grandson lost one, and once they got out of range, they're gone. But I see them further rolling out for areas of rescue, for surveying, for delivery, for agriculture, using autonomous mode and geofencing to say where you can go. They'll plot their thing, they'll know what else is in the airspace, and they'll plan their routes. And one last area, industrial analytics. I think this is a big area. Basically the IoT for industry, where you have sensors and automated systems in your factory and built into your products. So you can do smart manufacturing, but also smart operation. So GE has done this for years now. Their airplane engines, the blades are instrumented. So they can sense vibration. They can say, well, another 2,000 hours, we've got to pull that engine and do maintenance. It reports back. Their locomotives and so on. But I see this becoming predictive and prescriptive maintenance for products, following your products into the field, integrates machine learning, and is very useful for business intelligence. So I think those are some of the key big areas. There are a few issues. One of the biggest is the cost of housing in the San Francisco Bay Area. I mean, I could barely afford the house I bought 40 years ago. It's amazing what it's worth now. So it's hard to get living space, and we're very conservative. Since we're here, we like our neighborhoods to stay the way they are. We don't want more density or more drivers and so on. So it's a tough nut to try to put more housing in the Bay Area. But Measure A, we just passed. Hopefully over the next 3 to 4 years, we'll start doing some of that for us, building some of that housing so people who work here can live here. Getting enough educated technologists. Our universities aren't turning out enough. Hopefully we will staple green cards to every PhD certificate earned in America, something like that. The third area, disrupting of existing business models. We've seen this in all kinds of areas. We see Uber and Lyft disrupting the taxi services in major cities. Well, what about government technology, GovTech? That's going to accelerate that pace of technology into the management of government services at the state and federal level, at the local level, which should allow those governments to downsize, which is kind of anathema. But can you imagine having a government that's 5 or 10% smaller than it was 10 years before instead of always bigger? Maybe this will give us an opportunity to retrain and make more productive those people working on government bureaucracies. But the more broad area of retraining displaced workers hasn't been well addressed. We know we disrupt a lot of industries. We've got to think about what happens to all those people. The shared economy workers, those independent contractors that are out driving, they can drive 5 hours a week or 40 hours or 70 hours a week. They set their own schedules. But this is a tough business. How do you help them become more of a regular quasi-employee? And then the effects on infrastructure. For example, I mentioned having that Uber car come and pick you up in the morning and take you to work. Well, it's going to go do some more work, so you don't need that big parking lot out in front of your company anymore. You've got acres and acres of space that can be repurposed for something else, because you don't have to have these huge parking lots now that you share cars. Maybe at home you only have one car instead of three. You can turn your garage into a granny suite and more housing. There are all kinds of things that could happen there. And how about high-speed rail? By the time our California high-speed rail is built in 36, it may be obsolete. That may be $100 billion we spent that could have been spent elsewhere, because Interstate 5 will have these cars at 5-foot intervals going 90 miles an hour in that lane, and you're just playing cards or reading your tablet, and it's 2.5 hours to LA. Or maybe you take the tube that Elon Musk has proposed, and you hop into that thing and you're there. So this idea of rail is based upon looking backwards, not looking forwards. It's a real challenge.